Alright, the 2-second rule. What a thing. 2-second rule is essentially if you're driving on a road and you're between two cars, then the car in front of you has to be 2 seconds ahead of you. It's a general rule of thumb. That way it gives you enough time to react properly in case anything bad were to misfortunately happen to the car in front of you, so you don't crash into them, burn, and die. Now, these two beautiful representations of cars right here will give an accurate representation of what the 2-second rule is. There you go. See, Connor is staying approximately 2 seconds behind Avery. This way, if Avery were to, so to speak, stop, then Connor, well, epically fails. This is what happens when you don't stay 2 seconds behind at high velocities. Let's see proper use.
Because braking distance varies with the square velocity.
Exactly. Let's clean up this mess.
So as we just demonstrated, two cars going at a fast speed, the 2-second rule doesn't work just because braking distance varies with the square velocity. But let's say you think you're 2 seconds away when you're going slower. Let's see what happens.
Huh! I had enough time to react.
Now look at this. These two didn't hit each other just because they're not going as fast. So when Avery stops, Bobby isn't going to go as far by the time he reacts, and his braking distance won't be as far.
Exactly.
Oh, hey guys. Yeah, what's up?
Hello.
So, what are you doing?
We were just kind of talking about physics.
Oh, that's
Yeah,
that's cool. What kind of physics?
Braking distance.
Yeah, tell her about it, Avery.
It's pretty cool.
Well, since we live in Waterville, we only have sleds to get around with. So, braking distance varies with the square of velocity, as illustrated in the kinetic energy formula. 1/2 times mass times velocity squared.
Ballin'.
Connor, why don't you talk about something that's theoretically out of my mind?
Alright, so anyway, let's say that we're pushing Bobby at 5 miles an hour. And let's say that his braking distance would be 10 feet, which is pretty radical, but we're in the snow anyways. So, if you were to double his speed, you would quadruple the original braking distance, which would be 40 feet instead of 10. And then so on. If it was 3 times the original speed, then he would go 9-fold higher than the original braking distance. And if he went half the original speed, then his braking distance would be the square root of the original braking distance. So let's go see this.
Yes, let's.
Let's.
Yeah.
Now I'm going to try and push Bobby at 5 miles an hour. See how far he goes. Alright. Now I'm going to try and push Bobby at 10 miles an hour. So theoretically, he should go 4 times the original braking distance. Woo! That was so epic. Yep, I just paused life. Pretty cool. Anyways, let's go over reaction time. So this is a really speedy ninja with really fast reaction time. So she can dodge punches like the Matrix, basically. And this guy has terrible reaction time, like he's impaired 24/7. So if he goes to punch her, she can dodge it, but vice versa, Bobby won't be able to dodge it. It's like if this ninja was driving and there was a car accident in front of her and she was going like 80 miles an hour, she would have cat-like reflexes and be able to stop in time, but vice versa for him. That would suck. So let's see what happens when they fight.
hypothesize that Connor weighs 75 kilograms, and he is going at 2 meters a second. Then his momentum would be 150. And because he is in momentum... Fail. I'm so sorry. Let me read. Can you read that? I can't read that.
This is Connor. Connor is busy working away on his physics homework. But little does Connor know that physics is working on Connor as well. You see, Connor... Sorry. Go.
Oh, hello. Let's talk about braking distance. Since we live up in Waterville, we only have sleds to travel around. So, braking distance...
It's okay. Somebody's...
Oh, hello. Shit. In a sled at 5 miles per hour. So that means that we're going to adult to 10 miles per hour, which means that we will quadruple Bobby's speed to 40 feet. But other than that, that means that his stopping distance should be 3 times the original. So now we should go outside.
9 times.
What?
It's 9 times.
What'd I say?
Screw up!